Hi kids! Today we're going to be working on lesson 25, and this is a very important lesson in 5th grade. Very important. We're dividing a whole number by a unit fraction. Unit usually means when they put like a 1 on there. So I have a ton of notes and it is so important. So I'm going to try my best to explain it, and I hope we can get it done in 30 minutes. So when you divide a whole number, the whole number comes first. You cannot change the location of this number. It must stay first. After that, you're going to put the division sign, and then you're going to divide by whatever your fraction is. So I have a few sample problems, and I want to talk about what's happening here. So at first, I'm just dividing by a whole number. That's not part of the lesson. It's just saying, hey, if you divide 2 by 2, you get 1. But when you start dividing by smaller numbers, you're going to get more pieces. And so like 2 divided by 1 is 2. This is bigger than what I had before. 2 divided by a half, which is smaller than what I had, makes more pieces. 2 divided by half makes 1, 2, 3, 4 bags. Okay, so there are some different sample questions. 2 divided by a third makes 6 bags, and I don't have a model for that, but here we start to talk about what's happening with the numbers. So let's pay special attention to the 2 divided by 1/3. When you set it up, you have the whole, which you cannot move, it comes first, divided by 1/3. Now, the old way, and there was never an explanation for me, it was just, oh, you keep this, you change the sign, you flip the second fraction, and you multiply. Okay, well, why? Why would anybody be able to do that with a division problem? That's where the confusion would come in for me. Now, I'm pretty good at following orders, so I would just do it, and you will get the right answer. Keep the first number, leave it alone, change the sign, flip the second fraction, multiply. Why does that work? Let's go over here. Let me show you why. If you have a division problem, like 2 over 1, and you divide by 1/3, you can't divide. If I set this up like 2 divided by a third, you can't divide 1 by 3. Can't do it. 1 is too small. So you have to make an equivalent fraction for 2 over 1, and it has to be big enough so that you could divide by 3. So this is like the magic number. I need this number to be at least divisible by 3. So I just take my first whole and I make it equivalent. So I'm not changing it. I'm just making it equivalent to 2. And so I multiply by the scale factor of 3/3. Now, if I multiply 2 over 1 times 3/3, then I get 6/3. Okay? 2 times 3 is 6, and 1 times 3 is 3. Now, if you divide 6 by 3, you still get 2. See? It's still 2, even though it looks different. Now here's the division problem, 6/3 divided by 1/3. I can do that now. 6 divided by 1 is 6, and 3 divided by 3 is 1. And so I can get the answer by creating this division problem, finding an equivalent for the whole, doing the division, and I will get 6. But some smart math person, not me, realized that there was this procedure that was taking place, and that all you have to do, it's kind of a rule, is you can multiply by the reciprocal. What is this? This is a math word, and it means the opposite. Reciprocal means the opposite. If you change the operation to be the opposite, then you change the number you're multiplying or dividing by to be the opposite. So you're like double opposing yourself, which means you get the same answer that you would have gotten if you had just done it that first way. That's probably as clear as mud. But anyway, if you keep this 2, change your division sign to multiplication, then you're going to multiply by the opposite or the reciprocal of what you had before. So that's where the flip comes in. Keep it, change it, flip it. Okay, so you flip the second fraction so that it becomes 3 over 1 instead of 1 over 3. Multiply 2 times 3 and get 6. Okay, so write this down. When dividing fractions, and this is how your parents can do it, you can multiply by the reciprocal. Here's what you say. Keep it, change it, flip it. Okay, now I can't keep that there forever, so you have to pause the video if you want to look back at that. Okay, more practice. This is lesson 25. Divide a whole number by a unit fraction. If this is the whole and we have whole numbers, it's no problem. Here are your sample problems. So then if she has 2 pounds and she puts half pound in each bag, how many bags? She gets 4 bags. Okay, so here again, the reciprocal is the opposite. So if you have something that's a non-unit fraction, like 5/8, all you have to do is flip it. This is the reciprocal. If you have a fraction like 1/4, all you have to do is flip-flop, 4 on top, 1 on the bottom. So another sample, if I have 5 divided by half, and that's my problem, I can't solve 5/1 divided by a half because 1 can't be divided by 2. So make 5 an equivalent that has more pieces so that you can divide by 2. So if you multiply by 2 halves and you have an equivalent fraction for 5/1, so that becomes 10/2, which is still equivalent to 5. 10 divided by 2 is 5. You could solve it and get 10. But why do all this work when you can just keep it, change it, flip the second fraction, and then you get the answer? So throughout the lesson, sorry, let me move this up. Throughout the lesson, I almost never will do the division here. I am going to multiply by the reciprocal, and that's where the book will eventually take you. Now, I know that's a long explanation, but it's so, so important. Let's get to the book and see if we can finish this. If we can't finish it, I'm just going to show you the answers anyway. All right. You're going to draw, okay, we also have to use tape diagrams, so that can throw some people, but don't worry, I will get you through this. Draw a tape diagram and a number line to solve. You may draw the model that makes the most sense to you, which, if you weren't confused before, now you have 2 models that you can draw. Fill in the blanks that follow. Use the example to help you. So some kids will see 2 as the whole, broken into 2 parts. Here's one part. Here's another part. Okay, that's 2 pieces. Divide each one into thirds, because 1/3. So 1, 2, 3, 1, 2, 3. How many thirds are there? Well, there's 1, 2, 3, 4, 5, 6. And so this is how you can get the answer with those. So they also like you to show that you understand the thinking by saying there are 3/3 in one whole. 1, 2, 3, right here. 3/3 in one whole. See how it matches. And there are 6/3 in 2 wholes. 6 divided by 3 is 2. Equivalent. Okay? The other idea is if 2 is 1/3, what is the whole? So if 2 is 1 out of 3 parts, what would be the whole? And that would be 6. 2, 2, 2. Now, it just totally depends on how you see it. And so let's do a couple of samples and I'll try to show you each one. So if I have 4 divided by half, how many halves are in a whole? Well, let's make a tape diagram and check it out. Okay, I have 4 is my whole, and it's divided by half. Now, don't just put halves. Okay, we have to first show 4 parts. Okay, so each one of these, 1, 2, 3, 4, is a whole. That's 1, that's 2, 3, 4. It's like a number line. But I'm dividing each one into 2 parts. So yet another type of tape diagram that can help you see the answer. So how many parts are there? If this is a half and this is 1, or 2 halves, and then 3 halves, and then 4 halves, and then 5 halves, etc., then how many pieces do you have? And you can see that there are 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many halves are in 1? Oops, that's over here. That's not helpful if I point out the wrong thing. How many halves are in 1? 2 halves are in 1. So how many halves are in 4? And that's how, if you keep counting, you will see this is going to be the 6 halves and 7 halves and 8 halves. And 8 divided by 2 is 4. And so 8 halves in 4. So I hope this is clear for you. Now, this is the other part of that. So if 4 is, that means equals half, what is the whole? Well, that might be really easy for you to see because they're saying if 4 is half, then what is this up here? Well, that's pretty easy because you can just see that, well, if this is half, then this is the exact other side. So if you have your little number line and you go 1, 2, 3, so 0, 1, 2, 3, 4. So if that is 4, what is the whole? And the whole is 8. So couple different ways to kind of think about it, just depending on the wording. Remember that is means equals. Let's see if we can do another one. 2 divided by a fourth. So the whole is 2. Remember, the whole comes first here. 2. So how many pieces? 2. It's broken into 2 parts. But each one is broken into fourths. So this is 1/4, 2/4, 3/4, 4/4, because 4/4 is a whole number. That equals 1. This is 0/4, but if you don't write that, I'm okay. So how many fourths are in 1? There are 4/4 in 1. So how many fourths are going to be in 2? And so you can label all these, you can keep counting, but if you know that it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 8 fourths. Again, mathematically, 8 divided by 4 is 2, so there are 8 fourths in 2 wholes. And so there are 8 pieces. Now let me show you really quickly the way that you're going to be doing this. If I have 2 divided by 1/4, keep it, change it, flip it, multiply and solve. Okay, 4 divided by 1/2. That's your problem. This is 4/1. So keep it, change it, flip it, solve. Okay, so that's how you can do those. Now, another sample. If 2 is 1/4, if 2 is 1 out of 4 parts, what is the whole? 2, 4, 6, 8. There it is. Who do we appreciate? 8. 8. There we go. Let's turn it. Guess how many pages are in this lesson? 4 pages. It's like a monster. So focus. Come on, man. Thank you. Oh, listen. All right, so 5 divided by a third. Let's make another picture. I have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's pretend they're all the same size. And it's divided by 1/3. Each one is broken into 3 parts. Okay, so this is how many different 2/3, 3/3, because this is 1, this is 2, this is 3, this is 4, this is 5, and then you can just count. So if there are 3/3 in 1 whole, how many thirds are in 5 wholes? Basically, you're trying to create this math problem where you can divide 15 by 3 to get 5, right? So 15 thirds in 5 wholes, so 15. Because by the time I count them all up, I would have thirds. That's 3, 6, 9, 12, 15. So you're creating all these parts. I hope that's clear. Now, if 5 is 1/3, what is the whole? 15, because 5 times 3 is 15. Okay? We are moving. We're trucking. Okay, 3 divided by 1/5. Make 3. Now it's 3, so make 3 parts first. And then divide each one into fifths. 1, 2, oops, that was too big. 3, 4, 5. Okay? And if this is where I start to get like, I got to be really careful with my tape diagrams. I'll try to make the ones a little bit darker or put like dotted lines. That also works, and then you can kind of follow the work along a little bit easier. Okay, so if you're counting by fifths, you can label them 1/5, 2/5, 3/5, 4/5, 5/5 for 1 whole. So 5/5 in 1 whole. So how many fifths in 3 wholes? Well, you're counting by fives. 5, 10, 15. And equals 15. Now let's set this up. If I have 3/1 divided by 1/5, keep it the same, change it, flip it. If you multiply by the reciprocal, you'll still get the right answer. Okay? And if 3 is 1 out of 5 parts, I have to have 5 parts here. Let's pretend they're all the same size. And if 3 is 1 of the 5 parts, then what is the whole? 3, 6, 9, 12, 15, or 3 times 5, and then you get your 15, and there's your answer. So, pretty tricky, pretty tricky. Now, here's something else that's tricky. It says divide, then multiply to check. Okay? Now, for this one, this is the thing that we don't normally do, okay? So if I'm going to divide, I need to be able to have an equivalent, okay? So if I have 5/1 and I'm going to divide it by 1/2, like it says right here, I have to have an equivalent with, sorry, my abbreviation, with the same denominator. Okay, can you hear the geese outside? Okay, 5/1 divided by 1/2. So make this big enough to divide by the 2. So multiply it by 2/2. We're taking the 5/1 and multiplying it by 2/2. Okay, you're going to get 10/2. So this is the division part. We're going to divide by 1/2. 10 divided by 1 is 10. 2 divided by 2 is 1. And I get 10. Okay, so then we're going to take that 5. Oh, sorry. And then let me show you this way. 5, keep it, change the sign, multiply by the reciprocal, and get 10. So I'm checking with my multiplication. Okay, I'm getting the same answer that I got through division, which I didn't actually put here, but there it is. 10 divided by 1 is 10. Okay? Let's do another one. 3/1 divided by 1/2. Let's make this something we can work with. I need it to be 2. So 3/1 times 2/2 equals 6/2. So 6/2 divided by 1/2 equals 6 over, because 6 divided by 1 is 6, 2 divided by 2 is 1, so equals 6. So if this is 6, okay, let's do our 3/1, multiply by the reciprocal, and get 6. Okay, 4/1 divided by 1/5. I need 5 here. It has to be big enough to be divided by 5. So I'm going to take 4/1, multiply by 5/5, get 20/5, and when I solve that, I get 4. Okay, so, oops, sorry. 20/5. What did I do? I didn't do the division. Okay, I probably didn't need to erase that. 20/5 divided by 1/5. There we go. And then let's put the answer down here so I don't get into D. 20 divided by 1 is 20. 5 divided by 5 is 1. And that gives us 20 equals 20. Okay, sorry about that. It's totally smashed. And check it. 4/1. Keep it. Change it. Flip it. Multiply, solve. Do you see how this is so much easier? Like, that's all I would want to do if I was, well, past this lesson. That's really all I ever do. Okay, with 1, 1 divided by 1, 1 over 1 divided by 1/6. This has to be bigger. It's got to be at least 6. So take 1 times 6 sixths and get 6/6. Now divide by 1/6, the step I forgot over here, and get 6 over 1. So we get 6. Take the 1 over 1, multiply by the reciprocal, and you get 6 over 1, which is 6. Sometimes I just skip that step because it's annoying. It's like so repetitive. Okay, 2. Let's do another one. Oh my gosh. Okay. I'm gonna do something I don't like to do, but I'm just gonna show you the answers for this last section because it's such busy work. Okay, so if you do the division, 2 over 1 divided by 1/8, okay, this needs to be at least an 8. So you multiply by 8/8, get 16/8 and do the division. 16/8 divided by 1/8 is 16 over 1, which gives you 16. Then multiply to check. 2 over 1 multiplied by 8 over 1 equals 16. Bam, there's your answer. 7 over 1 divided by 1/6. Make this big enough to divide by 6, so multiply by 6. So 7 times 6 is 42. 1 times 6 is 6. I didn't even bother writing 6/6. I just went for it. Okay, 42, 6 divided by 1/6. 42 divided by 1 is 42. 6 divided by 6 is 1. 42 over 1 makes 42. Check it by multiplying by the reciprocal. 7 over 1, change the sign, flip the second fraction, you get 42, bam, you're done. Okay, this one, sorry, gotta block out this part. 8 over 1 divided by 1/3. I need something at least big enough for 3, so multiply by 3/3, get 24/3, divide by 1/3. 24 divided by 1 is 24. 3 divided by 3 is 1. 24 divided by 1 is 24. Check it with multiplication. 8 over 1, which is our original. Keep it, change it, flip, and you get 24. Okay? 9 over 1 divided by 1/4. Make this big enough to divide 4, so you multiply by 4/4. 9 times 4 is 36. 1 times 4 is 4. And then you have 36/4 divided by 1/4. That makes 36. Or keep it, change it, flip it, and get 36. Bam. There you go. So why do I want to do that? Because I still have 2 more pages. We only have like 8 minutes. And I want you to see the word problems. So for an art project, Mrs. Williams is dividing construction paper into fourths. How many fourths can she make from 5 pieces of construction paper? So the whole that she has is 5. So we're going to take 5 and we're going to divide that into fourths. So set it up with 5 divided by 1/4. Okay, remember that 5 as a whole number is really 5 over 1. So turn it into this nice fraction. Change your sign. Flip and multiply by the reciprocal. Reciprocal. Multiply by the reciprocal and get 20. She can make 20 pieces. P-I-E-C-E-S. Okay? And so you can have a tape diagram if you want. You can do the 5. You can do 1, 2, 3, 4, 5. Each one is divided into fourths. 4, 8, 12, 16, 20. And you see that you get the 20. So that would also work. Let's move on. This one has 1, 2, and then 2 on the back. Yep, there's still more. So you have to use the chart to answer the questions. Very realistic, okay? Hamburger, pickles, potato chips, chocolate milk. Each has a serving size of this amount. So how many hamburgers can Donnie make with 6 pounds of hamburger meat? If Donnie has 6, and that is the whole, he's going to divide it by a serving size. So hamburgers have 1/3. So you're going to keep the 6, okay? You have to keep the whole. If you keep it as 6, that's fine. If you wanted to divide it and make an equivalent fraction, you could still have times 3/3 and have 18/3. 18 thirds is still 6, okay? But why do all the rigmarole with changing all this when you can multiply by the flipped version and get your answer? He can make 18 burgers. Okay, so you can, if you understand it this way, do it both ways. Okay, how many pickle servings can be made from a jar of 15 pickles? This is my whole. So I'm going to take the 15 and I'm going to divide by the pickles. You get a fourth of a pickle. So it's going to be, this is my whole, keep it the same, multiply by the reciprocal, and solve. 5 times 4 is 20, and 4 times 1 is 4 plus 2 is 6. 60 pickle servings. Be sure and become a subscriber. Makes me so happy to be able to help you guys. So that's what this channel is for. I'm a professional helper. How many servings of chocolate milk can he serve from a gallon of milk? Okay, so also referring back to your page 167 if you need it, chocolate milk comes in half-cup servings and a gallon of milk. So you have to know that 1 gallon equals 16 cups. Okay, and that's on that page 167 reference sheet that I was talking about the other day. So you have 16 cups, which is your whole, divided by half-cup servings. Keep it, change it, flip it, multiply, 32 servings. Okay, but you have to know this in order to get the 16 for the whole. Then, finally, 3 gallons of water. Fill 1/4 of the elephant's pail at the zoo. We don't have any questions about the recipe or the menu from the previous page. This is a new problem. 3 gallons, fill 1/4 of the elephant's pail at the zoo. How much water does the pail hold? So for this one, we're looking at, look at the words. 3 gallons, fill 1/4. 3 gallons, fill 1/4. How much water does the pail hold? That is where they have now flipped the problem and are asking you about the whole. Okay, and it's basically like this. But if you want to take the division part of it and do 3, fill divided by 1/4, okay, then you would do 3, keep it, change it, flip it, and you get 12 that way too, 12 gallons. Either way, I mean, just kind of look at it. So yay, we did it, and I didn't get cut off, and I didn't lose Wi-Fi. Hooray! All right, I look forward to seeing you guys on the next video. I sure hope this was helpful. Bye!